What is up, guys? Welcome back to this YouTube channel. Today, this is the 7th part of exploring our entire solar system. So the last video we did Jupiter and its 4 Galilean moons, Io, Europa, Ganymede, and Callisto, where we talked about them, and even ones from 4 years ago. Now we're going to the next planet, which is the ringed planet of Saturn. And you may say, Saturn is the only planet with rings in our solar system. That is not true, because I highlighted that Jupiter has very faint rings that you can't see, and Uranus and Neptune also have small ring systems as well. But Saturn's rings are more famous than other rings. So the cool part about space engine is that you can actually go in the rings and see its particles. So let me go ahead and enter Saturn's rings. You can notice it's a ton of particles. Let me slow down the time. As you can notice, there's a lot of ring particles around Saturn. They're all orbiting very fast around Saturn because they're so small. And each of them are so small, they literally go from several millimeters to little kilometers in size, these ring particles. So that's the ring particles of Saturn. Anyways, Saturn takes 10 hours to rotate around and the solar day is also 10 hours. The actual tilt is actually 26, which is just 3 degrees more than the Earth's actual tilt, which is about 23 degrees. The age is 4.57. The atmosphere composition, just like most gas giants, is mostly hydrogen and helium. And the average temperature is colder than Jupiter because it's farther, being negative 140 degrees Celsius, and contains way more moons than Jupiter, having over 146 different moons, and 7 of them being the big moons, which are Mimas, Enceladus, Tethys, Dione, Rhea, Titan, and Iapetus. So before we tell you about that, let me tell you about Saturn more. So Saturn is about 116,000 kilometers, or 9 Earths. Its ESI is 0.24, and also and the pressure is very high, which is normal for a gas giant, you know. And the atmosphere and the physical compounds is 81% hydrogen, 33% helium, 15% water and ice, and 0.7% silicate, and 800 parts per million metal. Meaning the core on this planet is very small because the actual rocky part only makes up like less than 1% of Saturn, and the rest is all just hydrogen, helium, or water and ice. So, like I said, that Saturn has very big moons. There are even moons inside of Saturn's rings. One example is Pan, and Pan is an asteroid which has a disc in the shape, looks like a burger. You may think it's like, and actually it's inside Saturn's outer rings. That's the moon Pan. And another one, Atlas, which is actually outside of Saturn's rings but almost inside its rings. Another asteroid which takes 14 hours to orbit Saturn. So now this is Saturn and its amazing ring system. Let's go ahead and talk about its moon. The closest big moon to Saturn is Mimas, and Mimas is a frigid, airless micro-aquaria, and it's often called the Death Star moon because there's actually something cool about Mimas. Oh, there was a loon. Alright, there's something cool about Mimas, is that you can see a ginormous crater. If you can't see it probably, there's actually a ginormous crater in Mimas, which is why some people are calling it the Death Star moon, you know? And that's Mimas. It takes 22 hours to rotate. The temperature is almost negative 200 degrees, which means it's actually all of the moons are colder than Saturn because because most of them don't have atmosphere except for Titan. So that's Mimas, taking 22 hours to rotate. The actual tilt slightly. The gravity is literally very low, and it's actually smaller than the moon as well. Next up, Enceladus, which is something that you may have all known of because it's actually full of ice. Enceladus is completely iced up on the surface, and many people say that because of this, the ice on Enceladus is making it so that there's actually water underneath Enceladus's things. Yeah, there's actually a water, according to what many people think, taking 33 hours to orbit Saturn. And you may know what that pink dot is. That's Pandora. I don't know, whatever that is. We're gonna talk about that later. So its ESI is actually kind of low, 7%. The diameter is 500 kilometers, making it very small. So that means when the sun becomes a red giant, this will have life. We will talk about this later. And that's Enceladus, being 1% of Earth's gravity, and it's negative 214 degrees. Next up, Tethys, the third big moon of Saturn, and Tethys is actually also kind of larger. We're ramping up the scales right now. So Tethys is another microquarter taking 45 hours to rotate Saturn. Into actual tilt slightly. The gravity is also 1% of Earth. The temperature is also negative 202 degrees, and its diameter is 1,000 kilometers. ESI is 9.9%. And next up, Dione. And it takes 2 days to orbit Saturn, which has a kind of surprising surface, actually. I mean, kind of cool. I like the surface of Dione. So its rotational period, 2 days to orbit Saturn. The actual tilt is like slightly more like every other moon. Gravity is actually 2% of the Earth, and the temperature is actually kind of warmer than Enceladus and Tethys. But it's actually super cold still. ESI 11%, diameter 1,100 kilometers, and was discovered in 1684. And here's the difference with all the moons. Mimas was discovered in 1789. Mimas and Enceladus were discovered in 1789. Tethys and Dione was discovered in 1684. Rhea was discovered in 1672. Titan was discovered in 1665, and Iapetus was discovered in 1671. Let's go to Rhea now, another microquarter, taking 4 days to orbit Saturn. Its ESI is 12%, and the diameter is 1,500 kilometers. And it takes 4 days to orbit. The actual tilt slightly. The gravity is also 2%, and the average temperature is 194 degrees. So now the most surprising moon of all, Titan. Titan is also known as being the only moon in our solar system with a visible atmosphere. I say visible because some other moons in our solar system have atmospheres, but they're not really visible that much. And the great news is it has oceans. The bad news is it's mostly propane, ethane, and methane, and some nitrogen. You may expect it was water, but water cannot exist in negative 225 degrees temperatures. The atmosphere pressure is 1.4 atmospheres, and it's made of nitrogen and mostly methane. That's its atmosphere. Taking 16 days to orbit Saturn, ESI 25.4. And its diameter is actually larger than Mercury, being 5,000 kilometers, but smaller than Ganymede. And that's Titan. And here's another fact about Titan. Many people say Titan's gonna have water. It's gonna have life in like when the sun becomes extremely big. No, that's not gonna be possible, because when the sun does become a red giant, the habitable zone will be pushed into into Pluto or Neptune's orbit, because the sun will be so big. It'll be 256 times the sun right now, and it will happen in 8 billion years from now. So and Titan will definitely not have life because it'll be way out of the habitable zone. But still, it actually has some scientists ready to see if there's any life in Titan right now. But for now, no life is seen on Titan. This is Titan's surface. But if you enable clouds, it actually has a blanket of clouds on it. And the final moon is Iapetus, taking 79 days to orbit Saturn. It's actually kind of far away from Saturn. Look at Saturn over there. So that's Iapetus, taking 80 days to orbit. Its ESI is 14.5, diameter is 1,436 kilometers. Average temperature negative 185 degrees Celsius. 2% of Earth's gravity. ESI is 14.5 degrees. So that's all of Saturn's moons. And let's go. And before we end the video, we're gonna see the dwarf moon Pandora, which is actually another moon that looks like a thing, and it's 92 kilometers. So that pink dot, I don't know if it was Mars or anything, but that pink dot is just another asteroid taking 15 hours to orbit Saturn, called Pandora. And that's Saturn's moons. We didn't see all Saturn's moons. There's literally tons of moons, like 146. But anyways, that concludes our entire YouTube video. If you enjoyed this content, make sure to drop a sub onto our channel and leave a notification to watch more videos, or if you want to see Uranus, Neptune, and all of the dwarf planets. Adios, everyone. See ya.